Good afternoon, class. Today what I'd like to do is go over a word problem that would show how to translate this into this. Okay, this is if you have a hard time reading the red, or if there's that glare over here or the glare over here, then please feel free to follow me. This is number 26 in the Kinematic Reflection Questions Equation 1. Okay, so I will read the question to you, just in case it's also hard to see, because I wanted to distinguish everything by using red for the word problem, again, black for the things that will always stay the same, the variables and the units, and then green for all of the things that will change, which are the inputs, or the different numbers that I'm going to be putting in. And of course, keeping with the theme, blue is for the equation, because that will never change. So here we go. Number 26 states that a ball starts at 0 meters, has a starting velocity of 2 meters per second, an acceleration of 0 meters per second squared. It travels for 3 seconds horizontally. So the question becomes, how far did the ball travel? So now what we have to do is what we're doing essentially, it's the same procedure that we did in problems numbers 1 through 25. We want to get to this stage because, as we saw in the last video, you can do exactly, if you have this form, you can exactly follow the same procedures that I showed you in my shortcut method to solve it. The only additional step that is necessary for these other problems is simply translating this sentence, or maybe awkward paragraph, into this. So here we go. So we start with, we've got a ball and it starts. So as soon as you see the word start, this should already tell you we're talking about some initial, an initial something, whether it's starting velocity or starting position. So we need to, that should be one of the key words that you understand from this. So it starts at 0 meters. Well, that tells you 0 meters, that's a unit of distance, so we're talking about x initial. Then we start with a starting velocity, so that must be v initial for starting velocity of 2 meters per second. And acceleration, so right now that's my acceleration right there, 0 meters per second squared. And it travels horizontally, and this word horizontally tells me that this acceleration is in the x direction and not like the y direction. So it travels horizontally for 3 seconds. Well, seconds is obviously a unit of time, so we're going to stick that in there with time. So then they ask you, how far does the ball travel? Well, far is a unit, is a word that denotes distance. So that means we're looking for the unit of meters, which is definitely this final position, x, because the variable for distance is x. Okay, so now we're going to go again through the exact same steps. We're going to use the first kinematic equation, x equals x initial plus v initial t plus 1/2 a sub x t squared. I say that very fast because you've read that in the notes. You can see it again as well in the notes, even the one right above all the other problems that you've been working on. So what do I do from here? Same thing that I did last time. I rewrite the equation and I substitute all of the different numbers that I was given here in green. I substitute them in here for all the variables. This time I'm using the shortcut method, so I don't put in my units, and I'm just going to substitute just the numbers into here. So that's why I get 0 plus 2 times 3 plus 1/2 times 0 times 3 squared. From there, what I do is I just simply do math. So I've got x equals 0 plus 6 plus 0, which we can ignore the zeros, and it comes out to x equals 6 meters. So this would be how to translate a word problem that I wrote here in red all the way back into the exact same type of problem that you've been dealing with in the first half of these assignments. One thing that I'd like to note, while this is good for the kinematic reflection question equation 1, this actually applies exactly to equation 2 through 6, and it also applies to pretty much every other homework assignment that involves reflection questions coming from equations. So I just want to put that out there so that you have that idea that what you see here, this applies no matter what part of the year we're in, no matter what part of the course we're in. We will always be you can always use this technique, and it will work for all of the problems because I designed it that way. So that's to give you some hope, because I know there's a lot of problems that you have to do for homework, and I want to make sure that you have the technique that is required and necessary to help you overcome this challenge, because that's part of what we do here in physics. So thank you guys so much for that. Good luck on your homework, and may the force be with you.